Hey, grade 3 students, how is everything? First of all, Happy New Year to all of you. Miss Fatin misses you too much. Welcome to the first lecture video of this semester, semester 2, and this time we'll be talking about heat energy. So we're done talking about human body systems and we will start talking about something new, which is the heat energy. The sun is the main source of heat on Earth. It warms up all living and non-living things on our planet. So, water, objects, living beings on Earth take heat energy from the sun and heat up. Let's take a look on this picture. Here are some kids sitting in the sun. Tell me, what's the source of heat energy in this picture? What gives heat energy to the kids? It's the sun. And as we said, the sun sends heat energy to everything on Earth. For this reason, kids feel warm. What about this picture? The boy and his mom are cooking. What's the source of heat energy used to cook food? It's the stove. This can be an electric stove or a gas stove. So when your mom turns on the stove, the fuel or the gas changes into heat energy that cooks the food. The gas in here that burns is the source of heat energy. What is another kind of fuel that we use every day to produce heat energy? What is something that we burn to make heat? Actually, there are many, but I chose coal. Coal is an example of fuels that we use in our houses to produce heat energy. And also, we have the gasoline. The gasoline in the car burns and changes into heat energy. So you know now that coal, gasoline, and gas burn to produce heat energy. Here is an electric heater. And this time, in this picture, the electric heater is the source of heat energy. It is the equipment or the thing that gives us heat energy during winter time. So what are different sources of heat energy? What gives us heat energy? There are three different sources of heat energy: the sun, the gas stove, and the coal. I can add also the gasoline that we talked about. These use a special kind of energy that turns into heat energy. When something burns, so there are things burning in the sun, the gas in a stove burns to produce heat, coal burns also to produce heat, the gasoline burns to produce heat. Everything that burns is using a chemical energy, and it's the chemical energy that changes into heat energy. What about the electric stove or the electric heater? It's the electric energy, it's electricity. So these machines use electricity, and it's the electric energy that turns into heat energy. Miss Fatin, what is the third source of heat energy? Let's see. I want you to try something. Please rub your hands against each other for a while. Okay. Rubbing hands against one another produces heat energy. Here we say that it's the mechanical energy that turned into heat energy. Let's repeat this. There are three different sources of heat energy. Chemical energy, as we said, when things burn to produce heat energy, we say that we're talking about chemical energy. When electricity is used to produce heat energy, we say that it's the electric energy that produces the heat energy, that changes into heat energy. And last of all, when we rub objects against one another to produce heat energy, we say that it's the mechanical energy that turns into heat energy. Chemical energy, electric energy, mechanical energy. Again, chemical energy, electric energy, mechanical energy. Let's practice. Here's a question found on your book on page 129. We have different machines and equipment that we have in our houses, and we have to circle the equipment that is used to produce heat energy only. Heat energy only. Let's see. We have the mixer right here. We have the mixer. Do we use the mixer to produce heat? No, this is not right. We use it to mix things together in our kitchen. We do not use it to produce heat. What about a radio? Do we use radios to produce heat? Do radios provide us with heat energy? No, they don't. Telephones. Do phones provide us with heat? No, they don't. We use them to communicate with others. Here is a heater. The heater is used in winter time to produce heat, to warm us up. So, yes, this is the first equipment found in our houses and used to produce heat energy. The stove. We use the stove to cook food, and we use heat to cook this food. So yes, the stove is used to produce heat energy. The lamp? No, the lamp produces light and isn't used to produce heat energy. The TV? No, the TV also is not used to produce heat energy. What about the microwave? We use the microwaves in our kitchens to heat food, right? So, this is another equipment used in our houses to produce heat energy. The fan is not used to produce heat energy. The heater, the stove, and the microwave are equipment used in our houses to produce heat energy. Here is another question about these machines. What's the source of the heat energy in each of these equipments? Let's start with the stove. Okay, this is a gas stove. In here, it's the gas that burns to produce heat, right? It's the fuel. The gas is a kind of fuel. When burning, gas is a material that mixes with oxygen from the air to provide heat. So here we're talking about chemical energy, since things, as we said, when things burns, when like gas, gasoline, coal, oil burns, they produce heat, and here we talk about chemical energy. What about the electric heater? We use electricity to turn the heater on, so it's the electric energy that changes into heat energy, and it's the case for the microwave, since the microwave uses electricity to produce heat energy. So in here, we have two sources of heat energy. The chemical energy changes into heat energy, and also the electric energy changes into heat energy. Does heat move? Let's see. We'll start talking about transfer of heat. If heat moves from one place to another. Yes, heat moves. And heat moves from a hot place to a cold place. The man wearing red has more heat energy than the man wearing blue. So heat moves from the hot place, the place with a higher heat energy, to a place with less heat energy. Let's take this. Let's take this. Okay, the source of energy in this slide is fire. Wood burns to produce heat energy. So it's a chemical energy that changes into heat energy. The fire is the object or the place with the highest heat energy in this picture. So heat moves from the fire to these hands. Heat moves from the fire to the metallic stick. Heat moves from the fire to these hands. Again, heat moves from a hot place to a cold place. Let's do this activity together. Touch a cold glass of milk or a cold glass of water. Tell me, how do your hands feel when you touch something cold, a cold cup of juice, water, or milk? How do your hands feel? They feel cold, right? So, how did heat move? Let's think about this, okay? The cup of milk has less energy than your hands. Your hands were warmer than the cold glass of milk. The glass is cold, so it has a small amount or it doesn't have heat energy. Okay, your hands are warm, so they have more heat energy than the cold glass of milk. And as we said, heat moves from a hot place to a cold place. Okay, this means that heat in this case, so the hands have more heat energy than the cold cup, so heat moves from your hands to the cup, since the cup is colder. Another activity, you are tasting a bite of ice cream. Let's imagine this. You're eating ice cream right now. How does ice cream feel? Does it feel warm, hot, cold? How does it feel? It feels cold, right? Tell me. Try to explain, how does heat move in this case? Does it move from the ice cream to your mouth or from your mouth to the ice cream? Don't forget, heat moves from a hot place to a cold place. Which one is cold in this case? It's the ice cream, right? So, ice cream has less heat energy than your mouth, than your tongue. So heat moves from your mouth or from your tongue to the ice cream. And for this reason, you feel the cold of the ice cream. We have two solid blocks. They are heating to the temperatures shown. So these two blocks, one of them has a temperature of 20 degrees and the second one has a temperature of 5 degrees. The blocks are placed so they touch. Heat must move. How does heat move? Does it move from the block having a temperature of 20 degrees to the one having a temperature having of 5 degrees, or the opposite? Heat moves from the hot object with the highest temperature to the cold object having the lowest temperature. So, from the block having a temperature of 20 degrees to the block having a temperature of 5 degrees. So, this is my answer. This is right. Two other blocks. One of them has a temperature of 330. The second one has a temperature of 365. Different temperature, so heat energy moves from the one with the highest temperature to the one with the lowest temperature. So this answer is correct. This answer should be correct. Let me try. Is this correct? Correct. Two different blocks with different temperature. The first one has a temperature of 215. The second one has a temperature of 205. When objects have different temperature, heat energy moves from the one with more heat energy to the one with less heat energy. This means that this should be the correct answer. The first block has a higher temperature than the second one, so heat energy moves from the first one to the second one. And this is right. Let's try to do another activity, okay? If you want to do it at home, you will need the help of a grown-up, okay? Don't do it by yourself. Place 2 spoons in a cup containing a very hot water, boiling water. One spoon must be made in plastic, and the second one should be a metallic spoon. Okay, so place 2 different spoons in a very hot water. The first one is metallic, the second one is a plastic spoon, and wait for let's say 5 minutes. Okay, here is the plastic spoon and here is the metal spoon. After 5 minutes, tell me, how does each spoon feel? How does the plastic spoon feel? And how does the metallic spoon feel? After a while, you will notice that the metallic spoon feels hotter than the plastic spoon. Since heat passes through metals faster than it does through plastic. Heat passes through metals faster than it does through plastic. Okay? Here is another activity. You can ask your mom about this. In these two cases, we use different spoons. A wooden spoon, here is the wooden spoon, and also a metallic spoon. Okay? Don't forget that heat passes through metals faster than it does through other materials. Okay? In which case will be easier for your mother to hold the spoon if both pots are on fire. So both pots contain boiling materials. The things in the pots are very, very hot, and you have different kinds of spoons. Okay? In which case will it be easier for your mother to hold the spoon? Look, this is a metallic spoon, and as we said, metallic spoons feels hotter than other kinds of spoons. The metallic spoon feels hotter than the wooden spoon, so this will be more safe for your mother to hold. For this reason, it's better to use wooden spoons to cook, since heat doesn't pass through wood easily. Okay. Metals are good conductors of heat. They let heat pass through them easily. Again, here is a metal spoon. We saw and that the metallic spoon feels hotter than the plastic spoon in this activity. Here is also a metallic spoon. The metallic spoon feels hotter than the wooden spoon. Metals are good conductors of heat. They allow heat to pass through them easily. They become hot easily and faster than spoons made with other kinds of materials. The plastic spoon and the wood spoon didn't let heat pass through them easily. So we say that plastic and wood are bad conductors of heat. They do not allow heat to pass through them easily. Let's see. So you know now that heat doesn't pass in the same way in all materials. Heat does not pass in all materials in the same way. We have materials that are good conductors of heat, such as metal. Iron. Iron is a kind of metal, so it's a good conductor of heat. Iron is a type of metal, and metals are a good conductor of heat. What about wood? Wood is a bad conductor of heat. Cotton. Cottons are bad conductors of heat. Papers, bad conductors of heat. Gold. Gold is a kind of metal, and metals are good conductors of heat. So gold is a good conductor of heat. Wool, which is a kind of tissue. So cotton, wool are bad conductor of heat. So I will repeat. Heat does not move in the same way in all materials. Metals are good conductors of heat. They allow heat to pass through them easily. Bad conductors of heat, examples of good conductors of heat are iron, copper, aluminum, gold, and all of these are metals. Bad conductor of heat or insulators such as wool, cotton, paper, wood, plastic. In this activity, we'll be testing different materials, connecting the two beakers A and B. As you can see, beakers A and B have different temperature. We use thermometer to measure the temperature in each of the beakers. So in beaker A, the temperature is 95 degrees, and in beaker B, it's 5 degrees. Okay? It's the glass that is connecting, in this case, the two beakers. Let's see. Is the glass a good conductor of heat? Let me remind you that heat moves from a hot body to a cold body. So in this case, heat energy must move from beaker A to beaker B. I will choose to start with aluminum, which is a kind of metal, and metals are good conductor of heat. Look, heat energy is moving from beaker A to beaker B. The beaker A containing more heat energy lost some of its heat energy, and beaker B has now more heat energy. So heat energy moved from beaker A to beaker B easily, which means that aluminum is a good conductor of heat. What about glass? Okay, what about glass? Glass is it a bad conductor of heat or a good conductor of heat? Let's see. Is heat energy moving from beaker A to beaker B? Is the temperature changing? No. So heat energy is moving very, very, very slowly through glass. This means that glass is a bad conductor of heat. Here is another activity showing the power of insulators and in conductors in transferring heat from an object to another. Okay, now we're going to try to insulate the beaker. Take a look. The beaker has a temperature of 70 degrees, which is a high temperature. The beaker is hot, has a high temperature. Okay, we have three different materials: metal foil, polystyrene, and cardboard. Which one of these three is the best insulator? As you know, metals are good conductor of heat. So metals are not insulators at all. We still have two choices, polystyrene and cardboards. We saw that papers are bad conductors of heat. Let me try the cardboards. Cardboard are insulators, but there is another material that is a better thermal insulator. Let's see. Let's choose another material. It's not the metal foil, it's not the cardboard, so we still have the polystyrene. The polystyrene is an excellent insulator of heat. It does not let heat pass through easily. Okay, let's try. The room temperature is 18 degrees. The beaker's temperature is 70 degrees. What will happen when we cover this beaker with polystyrene? Look at the beaker's temperature. It is decreasing since polystyrene is an insulator. Did you notice how polystyrene blocked the transfer of heat? The polystyrene is an insulator. It decreases or it stops the transfer of heat. That's it for today. How heat is produced? Heat is produced when the temperature of something of an object rises and it becomes hot. Heat is produced from different sources. Heat energy comes from different sources, such as chemical energy. It's when fuel burns. Examples of sources of heat energy, sources of things that changes chemical energy into heat energy are the sun, the gas stove, the gasoline, oil, coals. All of these are fuel. When burning, they produce heat energy. Electric energy, when things or machines use electricity to produce heat energy, such as microwaves, electric stove, electric heater. Mechanical energy, when we rub things against one another. Heat passes from a hot body to a cold body. Heat moves from hot places to cold places. Good examples of good conductors of heat are metals such as gold, iron, copper, aluminum. Paper, wool, cotton, wood, plastic are bad conductors of heat. Thank you for watching. If you still have any questions about the lesson, you have my phone number. Please contact me. Bye bye.